Okay, we're going to look at a specific problem where we are going to find the stationary points of this cubic and determine their types, so determine whether they are maximums or minimums. So first of all, to work out where the stationary points are, I take the first derivative. So I write dy by dx, differentiate the original function, and I get 3x squared, take away 12x, plus 9. Okay, so stationary points occur when this derivative is equal to 0. So I set it equal to 0. Now, to make my life a little bit easier, I'm going to divide through by 3. Okay, so I get x squared, take away 4x, plus 3 is equal to 0, and you should be able to see that easily factorizes into x minus 3, x minus 1. So stationary points occur when x is 3 and when x is 1. Okay, now usually you would also work out what the y values are, so you would substitute x is 3 and x is 1 into the original equation, and that would tell you what y needs to be. Okay, that gives you the exact coordinates. I'm not going to do that here, I'm going to move straight on to using the second derivative. So to determine what types these stationary points are, the second derivative, d2y by dx squared, is used. Okay, so I differentiate this first derivative, and I get 6x take away 12. And I substitute in turn the two stationary points. So when x is 3, okay, I get 6 lots of 3 is 18, take away 12 is 6, which is greater than 0. If your solution is greater than 0, then that means this is a minimum. And when x is 1, we get 6 times 1 is 6, take away 12 is minus 6, which is less than 0, so x is 1 is a maximum point. Okay, so in actual fact, this actual cubic is looking something like this. Okay, here is your x is 1, the maximum point, and here is your x is 3, the minimum point.